This lecture is composed of two things. One, a set of tips and tricks that we usually present between Substrate and Frame module. They're pretty helpful for both, depending on the agenda. It could be either earlier or later. This time, this was its destiny. And I reorganized it and put together some extra things that were specifically regarding to the grading that we've done so far on the last week's assignment. So I started going through some people's assignment and leave some comments. Ankam would do the same. This will be ongoing throughout the week. And that's just some review for your code. It's not necessarily related to your grade. So first, I want to go over the things that were specific to the frameless assignment. It's not that many of them, but I think worth mentioning. First one, I was surprised to see formatters not being used, even though there was a Rust FMT configuration file provider. Just a suggestion, developer to developer, heart to heart. Use it. It's good. It's one extension you enable and makes life easier for yourself and your peers. Comment, yes.
So Rust formatter should be part of your plugin or something, so that whatever format you like and whatever has been committed, it converts it back to you and converts it back whenever it's committed.
That's next level of it, but
that's not an onus that you should put on developers.
Can you say again?
That's not an onus that you should put on developers. Yeah, community could be wrong.
Yeah, it's
consensus, 51% and more.
We can use different configurations files, but I think I clearly saw codes that were just not formatted. Again, I know that also the assignment last week, I understand it's kind of time bound, as in you're working under you don't care, just want to get the logic right. So a lot of my comments today are things that, again, I understand that when you're doing the assignment in 2.5 days, it's not your first priority, but now that it's over, I'm sharing it to help you be a better Rust developer, be a more professional Rust developer. I think you will hear it throughout this week's assignment as well, feedback or comments from Sean. I'm speculating, working with options and results is something that every time we see new Rust devs are unfamiliar with, and they use strange patterns. I have one example that I took from a random assignment that I was looking at last week, but can you have a look and now that, not under time pressure, see what's happening here? This is literally, I'll wait another 10 seconds. It's not wrong, by the way. It's correct, but it's you're re-implementing what this question mark operation is doing for you. This could be written the same way, and you just use this question mark. You do need to use this nice conversion function that converts an option to a result, and then this would be a more professional looking version of the same. Yeah, these are nitpicky things, but I still want to bring them up. Another one is using unwraps and panics. This was mentioned last week that it's something you should be careful about. I think this week is even more important. Now, sometimes you want your code to reasonably, you want to transform some option or result into the underlying value, and you're sure it's not going to panic. As in, you already have some if statement, maybe it's the line above, maybe it's elsewhere, that is giving you confidence this is fine. I just want to introduce you to another function instead of unwrap called expect that is literally the same. It's just a more professional way of doing it. So as the name suggests, with expect, you're saying I have evidence. I know for sure that this thing that I'm calling, this option or result, is not none or error. And then you also have the string parameter where the function is inviting you to describe to your future self, to your other colleague, why you are sure about it. So it's just much nicer than unwrapping, and then 3 weeks later you're looking at it and you're like, why am I unwrapping here? I don't really know. Am I a bad developer? When you see your expect, you can understand it better. I want to emphasize again, this is not it's not if I see this on your assignment last week, this has zero impact on your grade or whatever. It's just observations I had, and yes, okay, that's a very good point. So I'm telling them now because it will impact your grade. This week, you're expected to follow these rules, everything I mentioned. Yes. All right, now going to more generic tips and tricks and so on, some of the more generic substrate things. I want to reintroduce you to the most, in my opinion, the most important Rust syntax that is a barrier for entry for people to learn substrate and frame. You've already seen it a little bit, but in frame, it's like on steroids. You're going to see this a lot more often. It's called fully qualified syntax. When you say some particular type, as some particular trait that is implemented on that type, and then you access some associated type. This is like very, very ubiquitous within frame. Just to give you a simple example of it, so imagine you have, actually let me go a bit further forward so you can have a look for yourself first. So this is also something that in your assignment 0, even in the template given to you last week, actually no, this config traits, we didn't have them in your template last week. When your assignment 0 is present and you see it in frame, very often you have like a trait config that is a bundle of a number of associated types. And then knowing this, like this line, I really hope, and like right now or after this lecture, come to me so I can help you. It's really important that you understand what this type alias is doing, like how it's operating under the hood, how it's transforming some generic of some type named T that potentially implements config and gets the extrinsic associated type from it. Like you start from one generic and you go inside. And you can use the same thing then in a function, that's less relevant. But then we can then have the same process but nested. So the header associated type of trait config itself implements another trait called header T. And header T has another associated type called number. And then you can do the same thing but twice. So you start from C as config header, then this whole thing as header T get number. And then there are examples where it's like tree level. I mean, you don't need to these things you also get through pattern recognition, through habit. But I think this example hopefully is like simple enough that you can also get an actual understanding from it. You're going to see these type aliases next week, just an intro to them, so you won't be like more shocked, but not necessary to spend more time on them now. So this is one part where I partially regret it wasn't covered before last week, because I think it led to some issues, let's say. So I solved a lot of like one-on-one issues where people were, for example, adding prints to their runtime or using like the standard library in their runtime, and then there was some weird compilation error, and the answer is here. So we didn't explicitly have this in the curriculum, at least in lectures. It was in speaker notes or elsewhere, where when you compile Rust code to WASM, you are operating an environment called No-std. And this means that the standard library is not available to you. The standard library is a set of functions, types, utilities, and so on that different programming languages provide. They're usually a unified abstraction over the operating system. It gives you like an allocator. It gives you like standard collections, maps and vectors, these kind of things. And when you're operating in No-std, you're operating in a subset of the standard library that's called core in Rust, in which you still have a vector, you still have like a B-tree set, you still have things. Well, you don't have an allocator, for example, but that's not something you need to deal with. Point being, you can't import like std-vec or whatever in your runtime. If you do, or you can use printline. Printline is also something that is heavily backed by the standard library because it's talking to a console. This console is like an external interface for your application and so on. So there are certain things that are not available because of being in the No-std environment. And I'll talk more about prints next, but before going further, I want to talk about cargo feature flags, and then in the next slide I'll talk about how we use feature flags to compose applications that compile both to std and No-std. So feature flags are Rust's way of having conditional compilation. So you can have crates that have a part of their code behind a feature flag, and this may or may not compile depending on whether this flag is enabled. And what I want to convey here is just that these features are defined in your cargo.toml, and when you're bringing in dependencies, this is the syntax where, that's this last line, where you can say, hey, bring in this dependency called additional features, and bring it in with some extra feature. So this is like this slash something, is you're saying bring in this dependency, but with the additional feature of on steroids, whatever it means. And then there's a convention in the Rust ecosystem that Parity and Polkadot and Substrate also adopts for crates that want to compile to both like No-std environment and std environment. We actually add a feature flag called std. So when you are bringing dependencies within Substrate, within Frame, you very often see this pattern. But this pattern is also something that I bet you're going to learn just through seeing and repetition, pattern recognition. But it's good to get an intuition of what's going on, at least under the hood. So you're bringing in a bunch of dependencies. And these dependencies are all programmed such that if you use them with a feature called std, they work normally. They work with the standard library. They're doing their full capabilities. If not, they are ready to be compiled in a No-std, aka WebAssembly environment. So when you import them, you always import them, and you say without default features. So no feature comes in by default. And then you have this pattern always where you specify a feature on your local crate called std, which pulls in the std of all your dependencies. Okay, I know that was a bit of a maze, perhaps. Maybe I'll wait here. And this is something you will see over and over again. And yes, let me just finish my. This is a pattern that you will see over and over again, and I guess I want you to be familiar with it. Maybe you can revise this later to get a deeper understanding of it. Now a question.
Yep.
Yes.
Marisha. So in the default features and the feature std. So, but we don't require the std feature in the WASM environment. So why are we kind of putting that flag as the default features are std and with these dependencies, and we're not we're not fetching with the default features? Why are we kind of going extra miles and
it's for testing and native runtime. So I think for native runtime will go away as we discussed in the future, but it's still like for testing. I think like doing debugging in WebAssembly environment is like apparently still very painful. So I don't think even when the native runtime goes away, Frame is going to get rid of this paradigm of. It's also the
Okay.
Like having like a feature called std and enabling your crates to compile in this dual mode is a common Rust thing. Yeah, in theory, if we completely get rid of native runtime, and if we are really like sure that WebAssembly debugging is amazing and you can have backtraces, which you cannot, then we could actually get rid of, and all of the crates will be just marked No-std, and that's it.
Yeah, okay, sure.
All right. This is so you will see frame palettes, frame runtimes, even your template last week. The root file of your crate is always like annotated with this line, which is like what enables this whole system to exist, with saying if a feature called std is not present, compile at a No-std environment. And some people also accidentally removed this line or moved it around, and it caused chaos again. Like now I updated the assignment template to actually be very explicit on like do not touch this line, do not touch this line, and so on. So this is also just a hint, or I hope to give you a bit of like visual memory on a very common and obscure error that you might see if you actually mess with your std features. Like you bring in a dependency. I think the most common scenario where you see this weird error is when you bring in a dependency and you forget to do that feature gating system where you bring it in with default features false and then you conditionally enable it. I think the error is saying like some low-level things like like panic or OOM and so on, or duplicate. It goes back to, I think, both the Rust standard library being present and the core standard library being present. But yeah, you will probably see this in your career as a frame developer. And know that it has to do with STD features being messed up. But of course, as I mentioned, it's not like in this No-std environment, you can use vector and so on. In your template and your code, you already use vector and it worked fine. How did that happen? They were all using this core. Is this part of Rust called core, which we don't require you as Substrate and Frame devs to deal with directly. Substrate comes with a crate called SPSTD, so Substrate Primitives STD, which has a prelude, and this was already in your template last week, and if you import all the preludes, it will bring in all the things that you would need, like vector, for example. All right, so an appendix to the same conversation about STD is logging and prints, how you go about doing them. I want to first, before going into the main topic, again, mention that prints and logging in runtime is possible, but it follows a different path. You can't use println. Println by default expect a console to be present, and in a no-std environment like WebAssembly, there is no console. You need to do it in a different way. And everything that I say here is about that different way, not with println. I talk about that as well further in the slides, but I just want to emphasize again before going further. The dimension that I want to add here is that we care even more about logging within the context of a runtime, because at the end of the day, the runtime is like this blob that we are sending to the blockchain. It's a little bit treated, same way that contracts are treated, or any code that is portable is created. The size matters here. Like, you don't want it to be big. You don't want it to be littered with information that is not critical. So you want to strip it down as possible. And for those of you who are more, I don't know, into lower level programming, you will know that logging, surprisingly, actually has a lot of overhead on the size of your code. Because every time you're logging something in your code, that string literal, like, you're logging, hey, what a good day. That string, hey, what a good day, is literally somewhere in your binary. Your binary doesn't like calculate this string on the fly. It's stored in your binary. In my speaker notes, I actually have some commands that you can run, and from a WASM blob, you can actually get all the string literals that are scattered in it. So yeah, size matters. Logging increases the size. So if you have like something like this, and you derive the default Rust debug, it's going to generate some code that contains all the string literals. It's going to contain the struct name, all the field names, all of that stuff. Yep. Where are the throwable mines?
Okay. So for I can assume the format debug trait, more or less, that's only for like when you're actually in development, more or less. You would not have this trait on release, basically.
I mean, you could, but it would add all these things to your runtime, like all these string literals, and that's where I want to go next. So let's talk about that. There's the standard libraries debug, which you can use as SPSTD, FMT debug, and then Substrate comes with another debug derive macro you can get from SP debug derive runtime debug. Although I think it's re-exported from a lot of other places, so you can find it in other locations as well. And the code that it generates, it's quite interesting. I'll give you 30 seconds or something to have a look for yourself. And this might ring a bell. This part that says WASM stripped, I bet some of you have seen it. Have you? Like in your logs and so on? Okay, well, I'll explain it next, but have a look first. So I have this here as an example because I think it's also a good, very simple intro into like feature-gated programs or feature-gated snippets of code. So this runtime debug drive macro expands to a code like this, which is basically saying if I'm in feature STD, so normal mode of operation, in testing or when there's some native runtime going on, do the normal printing, which contains all the string literals I talked about. But if I'm not in that environment, I'm in the no-std environment, just print this, which in your current runtime from last week, a lot of types actually are derived from runtime debug, like they're using runtime debug. So usually, at least when I was running my tests or sometimes your test, I would see this string a lot, wasm stripped. It's just like a random string. But the good thing about this is that this is now only repeated once in my entire binary. Even if like 100 different types derive runtime debug, it's just one additional string literal. All right, so this was all about size and like a bit of a micro optimization, but I think an interesting one to know. Here, I just want to emphasize again that no matter if you're deriving debug or runtime debug, println and or this dbg debug macro in Rust, I don't know how many people use it or are familiar with it. It's kind of like println, but nicer for debug, are not available to you by default. You can't use them in your runtime and expect your runtime to then compile to WASM. You can use it for testing. You can sprinkle this in your runtime and cargo test will work, but cargo build should not work. I think some people who kind of did cargo build and claimed that their WASM file doesn't upload, my guess is that this may have played a role in it, but I'm not sure. I never got into the bottom of that issue from last week. And finally, logging. Like there's also the official logging libraries available to you in runtime, which you can use, but you need to learn how to set them up, and I have a brief intro to it here. So you can use this log crate, which is also available in runtime. You specify a level for your log, like info, or debug, or trace, or warning, or whatever. You specify a log target, which is quite nice, so you can filter based on different targets. You know, one module or one subset of your system will specify a target, and this is like an identifier that uniquely, you can then filter logs by a specific target. You can only narrow it down to a specific section, and the rest of it is like a normal print. And if you have, this is the more important part, which was mentioned in the assignment from last week, but I think lots of people didn't get to that part of it or didn't get their attention. In order to enable logs, you do need to specify them as an environment variable when you do cargo run, or pass it as a command line argument. And finally, the log crate itself doesn't like do the printing itself. It just like, you know, it pushes them to another entity that should do the printing. And in Substrate, you can use SP tracing. Like you need any environment in which you want your logs to be captured and actually print, you need to add this line to it. In the Rust ecosystem, it's another crate that's often used. It's called nvlogger. Maybe you've heard the name. All right. How's about logging? Any questions, comments? Good. Okay. Moving on. One of the other idiosyncrasies of runtimes that you should know about is that we deal with numbers a little bit differently. Floating point numbers are available to us under the curtain, under the hood, if you want. I mean, there are, like, for example, SB-STD doesn't. I mean, let's leave it at that. I don't want to actually think it's more of a bad advice. Let's assume they're not available for now. And the reason for that is that floating point numbers are often implemented by different vendors or different architectures differently, such that it's hard to come to consensus about them. Like it's harder to encode them, transmit them, and have someone else on a different machine, different computer exactly verify that, yes, it's the same number. What I'm trying to say is that it's like, but at the same time, we know that the need for determinism is like absolute in blockchains. We absolutely need to make sure I execute this state machine with this input and I come up with the same output. You do the same and you should come with the same output. It should be verifiable. And it would be very bad if there is even a slightest difference on, you know, someone's balance on my machine and yours. I mean, it's been years. I knew about this stuff more in my bachelor's. Years have gone by, but if you still Google things like weird float behavior or like, I don't know, floating point operation, undeterminism, whatever, in Google, you'll come up with interesting examples from different programming languages where these weird things happen. So 0.2 plus 0.2 plus 0.2 not equals 6, for example. I think these are from Python, all of them, either Python or JavaScript. And we don't want these things. These are just some examples of why floating points are a little bit frowned upon in contexts where we want deterministic execution. And what we use instead, we emulate the same types using fixed point arithmetic. Fixed point arithmetic is kind of like a shoestring implementation of what the CPU is doing on its floating point unit anyway, but at the higher level, such that we can ensure determinism. As in, we represent something like a % using a number, using just an integer number. So imagine you have a wrapper type called percent. It's 1 U8, and this U8 is just, if it's 1, represents 1%. If it's 100, represents 100%. If you implement it right, it can never be more than 100 as well. Like the inner U8 should never be more than 100. Okay, pause. And then Rust provides nice abstractions to actually make writing such types nicer or not too difficult, and using them also not too difficult. So for example, last section is also quite interesting. So we can actually have this wrapper type, and we implement like multiplication with U32. So you can easily have this percent type and multiply it by U32s and get exactly the same behavior that you would get with floats in a nice way. Does anyone know the name of what we're doing here when you have a type that is in Rust? When we have a type, as in a struct or an enum, but it's only wrapping something else, has a name. Yeah, please. Sum type. New type. I've heard maybe that's another synonym, but I've heard new type. These are called new type usually in Rust. Yeah, and in Substrate there's a crate called SP arithmetic, which I used to go over more details in this lecture, but I moved them to speaker notes. You can have a look for yourself because the documentation and so on has improved there a little bit. It's full of these types that are emulating fixed point arithmetic, and you can use them. And the APIs are fairly intuitive and nice. You can, build, for example, we have percent as well, but we want oftentimes more precision than 1% because, percent is like, it's not very precise. We have things like per mil, so parts per million, parts per billion. This one is parts per billion. So your precision is the smallest value that you can represent is 1 divided by 10 to the power of 9 with this type. Some of the constructors, from raw parts, from percent, from rational, so you're building 25% there with 1/4. And as I said, all of these types do their best as much as Rust to the extent that Rust as a language allows to have APIs that make working with them seamless. So you can easily multiply them, for example, with another number, and it would work. They're also implemented in a safe way. They've been audited, so they are used quite a lot. And we do the same, not just for necessarily numbers that are between 0 and 1. We can also do the same with larger numbers. So you can have the same idea, but you would say, for example, my base is 100, so then the number 100 is representing 1. The number 50 is representing half. Number 200 is representing 2, and so on. And then you can represent things like 17.2. Now you can have a fixed point representation of such numbers. And these are in Substrate, again, in the same crate, but this time they're called fixed something. So fixed U64. A fixed point representation that is using U64 as backend. It can represent numbers in a certain range. Again, well documented, nice APIs. You can go and have a look after the class or whenever you need them in your assignment. I think you will need them in almost all assignments. You would need, okay, I'm not sure all, but in many of your assignments, for this week, you will need to do some kind of arithmetic. If anything, it's like the first thing that the blockchains do, right? Arithmetic in a more complicated way. Right. So speaking of math, let's talk about fallibility. I'm a bit doubtful about the pronunciation of that one, but the fact that these operations can all fail. Because of reasons mentioned around panics and the fact that we want our runtimes to be safe and not panic, not do anything unexpected, it matters to know about the fact that arithmetic operations can also fail. So just a reminder, a lot of arithmetic operations are such that they panic. If an overflow or an underflow happens, they panic on debug mode, and they actually silently overflow or underflow on release mode. So this is just a behavior that you should know. It's not necessarily good news in any way, but not that and you usually use release builds in your actual production runtime. So it's not like, yeah, it doesn't panic on production. It's still not good. Like, it's still undefined behavior by all means, and you should avoid it. But just so you know, arithmetic operations panic on debug, silently overflow or underflow on release builds. And there's generally two ways to do arithmetic operations, such as like addition, division, and so on, in a safer way. One is checked operations, so that you just like, and checked operations, they don't return you a result or the outcome out of the box, they give you an option of something. So you can do A, checked B, add, and it will give you an optional value, and if that option is none, it means the operation was not possible, as in an overflow happened. Or saturating, which is a more reasonable silent failure, or a silent way to deal with it, as in the operation would just saturate. So if it's an addition, it would be the maximum value of that type. So if you have like 4 billion plus 4 billion in U32, the saturating addition would be U32 max, which is 4 billion something, because more than that it's not possible. But if you do checked add, it would return none. So you would have an opportunity to handle it. I think most often you want to go with the first one, but it's good to know the second one also exists. I'll talk more about the second one and in the context as well, but let's talk about why you want to do second one over the first one. Maybe it's a good time. Anyone have a suggestion or anything they want to say, or should I go? Yeah. Student.
I guess that there was a use cases in the assignment when a user pays too much tip,
Yeah.
and the priority of the transaction is an unsigned 64.
Yeah, I think so. I think that's a good use case. That's a good example, and it demonstrates the class of scenarios I want to talk about. Most often, you want to use checked arithmetic, and if something goes wrong, you can do something about it. You can revert. You can decide to do otherwise. But there are cases where you reasonably cannot do. Like the best you can do is just continue and. Oh, I hope this doesn't block. Okay. The best you can do is continue and move forward. Like I think in all of our runtime still, like when you add balances, we use saturating arithmetic. Like to use checked, it's gonna like make the code a lot more ugly to look like. And if the balance type is saturating, it means like we know, for example, runtime is using U128 as balance. That's like a massive capacity. We know the issuance of this network, for example, Polkadot is 10 billion or whatever. Like for 10 billion dots to reach that, it's going to be, millions of years must have passed by, or the system must have failed. So we rather just say, okay, saturating add, and we're good. As in, this is the bullet we rather take. I'll talk about this more in further slides as well. Oh yeah, so conversion is also like similar. If you're in debug mode, a conversion that should not happen will not happen, and as in it will panic. And in production and in release build, it would silently, it will wrap it would throw away some bytes, and it would give you a number, but it should still be classified as undefined behavior, and you should not rely on it. So for conversion as well, Rust gives very nice traits that you should be familiar with. From, into, try from, try into. Probably have all seen it. Let's talk a little bit about them in the context of numbers. Yeah, I guess I just have like 2 examples here for you to look at. Like these examples are taken from the standard library. They just represent that what from or try from, what is the difference, and in which context they're used. So when you implement something like implement from U16 to U32, it means a U16 number can always be made into U32 because U32 is a bigger capacity, so it's an infallible conversion operation. Whereas the try variants are for the other way around. And then very often within Substrate and Frame, we deal with generic numbers. So we have a numeric type like balance. We already hinted at it. So even in your assignment 0, I think we had like a generic balance type somewhere. But if not, you'll see it this week. You'll see it the moment you see like the frames balances palette. You'll see that even something like the balance type is generic. And when you're dealing with generic numbers, I like these examples because they're showing how we use these from into to represent generic numbers. So when we have something like the first example, a number that is from U32, what are we basically saying there? What numbers are from U32? Bigger ones, exactly. So you're basically saying T is like some type that is bigger than U32. And when you have into U32, it's the opposite. Types that are smaller than U32. And then if it's try into, you're not really specifying it. That's different use cases. All right. Let's continue. Now I think the examples and details would get a little bit more frame-oriented, but there's still like general tips and advice. I want to give you a reminder, a retro about this get trait. You've all implemented this in your assignment before the course. You also implemented a macro that will, I think you even had this blanket implementation, right? Yeah, these are also, yeah, just a reminder for all of them. And this get trait is like a very frame idiomatic primitive that we use. It's used to convey some value through a type. And we'll see an example of that later. So okay, I can go through this stuff much faster now, or you've already seen it. You've even implemented exactly this macro, a macro that implements getTrait readily. I just want to give you the fact that the name in frame is called parameter types, the name of the macro that is actually in frame and does the same thing. And it does more things than what you implement in your pre-course exam, but just the intro to it or a reminder of it. Another primitive that's used a lot in frame is bounded data collections, such as vector, slice, B-tree map, and so on. I have bounded slice twice there, sorry. I don't want to go too much into the context, but usually in blockchains are constrained resourced environment, as in we have limited time to do things and we have limited memory to do things. So it's reasonable to have some data types that ensure when you're iterating over vector, there's at the compile time, there's some guarantees that, for example, this vector is no bigger than a certain amount. And these bounded collections are all implemented actually using the lovely get trait that we just saw. So you can see it's like bounded vec, and inside of it is nothing more than a normal vec. So this is also a new type, by the way. And it's using this get trait to store what is my limit. And there's two benefits to doing it in this way. I won't answer what those two are before we go to the next slide and show you a different implementation of bounded vec. So this time we're doing, again, a new type. So it's like just bounded vec. Inside of it is a vec. And we're storing the just like limit as a, as a value inside of my vec. So what are the advantages of the previous one over this one? Or the other way around? Maybe this one is more advantageous. Please.
This is restricting to only U32, whereas in the previous one we can really be generic.
No, this is also the bound is still get of U32. So the bound in both of them must be a U32.
Okay, but we can give a custom name which implements the get.
Okay, but yeah.
Okay.
Okay. All right. So let's just, I'll continue, but these are, yeah, I'll just continue. The two advantages. One is that here, the bound that we have is represented as a type, which means you have more compile time guarantees at a high level. Like whatever is the bound can be checked, for example, whatever implements this S can be checked at compile time to implement get and be smaller than a certain value. It's harder to do, like it's not possible to do those things at compile time if your bound is a value. This is more advanced, but I think the more simpler advantage that I hope you see is that if we do it this way, every instance of bounded vec is storing like its bound, individual bound. So it's like an extra, 4 bytes that is attached to every single bounded vec. Every single bounded vec has an extra 4 bytes of memory footprint, stack footprint, state footprint, and so on. Whereas if the bound is conveyed as this type, it's actually just it's just for the compiler to ensure things, or that the actual value, the actual bound, is not stored all over the place. I'll let you ruminate on this on your own and later. I think also when you learn the type system more in a more advanced way. But TLDR, this magic of conveying values through types enables us to have more safety, like more compile time checks, and it saves space very often. So another trait that I want to introduce, and this one is just for the sake of an example that comes next. It's called convert. This is also something that you see in many frame palettes. Here I mainly have it to remind you of what it means to have a blanket implementation, which again, based on the assignment you've all seen. But I think this also has a funky blanket implementation. I'll give you a few seconds to have a look. So we're saying there's a struct called identity that implements convert for any type to itself. So it's in a, this is how this line, this is how I wish you to be able to read this line. For any type t, implement convert of t to that t itself for struct identity. This one's less useful, but I want to use it in my example next. It's one of the main reasons I introduced it. So now I want to take you back to the first slide, which was, please remember this syntax of type as trait associated type, because very often in Frame you have palettes that have a config trait with a similar vibe, with a similar look, and then you want to use items from this config trait within the rest of your code. So the rest of your code, and somewhere else in your runtime you have some type called runtime that actually implements these things, but that's a lesser important part. But what is the more important part? God damn it, there's a angle bracket missing here. But what's more important is that once something implements this config, you can always access these types that were parameterized in it, such as maximum size or converter, as with this syntax, which we reviewed at the beginning of this lecture. Type as trait associated type. I'll repeat, type as trait associated type. So you have a syntax like this, runtime as config, then we can get the converter, and then we know this converter is something that, for example, implements the convert trait, which we saw before, therefore it has a function called convert. Or within your palette, usually it looks like this. This is a bit low, I hope everyone sees it. I wish there was a way to, okay. Within your palette, it could also look like this. So you have like, not a concrete type that implements config, but some generic. So there exists some T, which will come in the future, or at a different stage, that implements config, and then you can do the same thing. So this syntax is something that you will see a lot for the rest of this week. Clear? Good. Or someone? I think I saw someone. Oh, okay.
Yes, please. Why do you need to say runtime as config and not only runtime?
Yeah, it's both are actually possible. Some like the fully qualified syntax is the most correct way or the most disambiguated. If in the context it's not ambiguous for the compiler to know which trait of a particular type you're referring to, then you can just say runtime : converter dot convert convert.
This means that you are making the user of this instance less specialized, right? So it will only know if you, for example, if you assign this call to a variable, it will lose things that are implemented for runtime that are not in config. You know?
I don't know what you mean by assigning.
So I mean, when you do runtime as config, blah 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 blah, blah convert.
Mm-hmm.
When you do as config, you lose everything from runtime that is not config, right? Because if runtime implements other stuff.
Yeah, but this is a function call. It's going to return a value, and it's not going to have. I mean, I kind of get what you're saying, but I don't think it's not a right way to think about it. As in, because if you just say runtime converter converts first, so you ignore the as config part, it's identical. There's no difference between the two. So I don't agree with. I don't think it's a right mindset to say we're losing some information.
It's identical, but for example, imagine that you have implement Sprubbles for runtime, whereas Sprubble is another trait. If runtime implements
another trait
different traits,
yeah.
Then if you do runtime as config, you lose all the other functions of the other
But
trait.
that losing is what we want, because we want to disambiguate, right? You want to imagine there's another config called config2. It also has a converter associated type. And when you just say runtime converter convert, the compiler is not sure which one you're referring to.
Okay.
So actually, that's what we want. This syntax is called fully qualified syntax. The name is kind of said. It's the most comprehensive way that you can annotate these things.
And what happens if the runtime implements two different types that have the same interface,
That's
you got error.
That's exactly why fully qualified syntax exists in Rust. As in, then when you want to call a method, you have to specify runtime as which trait, right?
Okay.
And then it's disambiguated.
Okay.
Yeah.
Is this something similar to dependency injection?
Dependency injection.
Because one you're trying to convert, and I'm just thinking like 64 to 32, right? So is this something similar to what you're trying? Because one can implement one trait and the other can implement the other trait, and whichever you want, you can use. Is that the scenario here, or I'm not getting it properly?
I'm not. I don't think so. At least based on what you said, I don't see that analogy. But
Converter. What's the purpose of the converter then?
oh, it's just an example. Like the trait is just an example. I introduced that trait solely to give you this example and familiarize you with the syntax.
Okay.
Yeah.
Thanks.
So another idiom that again you have implemented in your pre-course exam, so hopefully all the pieces come to place, is the idea that we often have different types and they individually implement a trait. Like let's say there's 3 different modules and there's a trait called onInitialize, maybe a familiar name, and they individually implement this onInitialize guy. It would be very convenient if there was a way we can group these 3 modules and operate on them as one entity. And the rustic or the Rust way of doing that is by grouping them together as a tuple. So very often you see in Substrate, in Frame specifically, traits that have this capacity that they can be implemented and then therefore executed upon a single type or a tuple of types that individually have that. Am I memory blanking? You have this in your exam? Yeah. Okay. So I'm assuming you're already familiar, so I won't go into a lot of detail. But I think this is the point where I want you to remember it, or maybe later today, if you don't quite remember, you can go back to your exam and read the code or read this. This is again a very common pattern within Frame. And the only syntax I want you to take away from it is that we use like an advanced attribute macro to implement this functionality on top of like Frame traits. Like, there's a lot of traits that are provided by Frame, you just use them. But if in the source code you see that they're annotated with this attribute macro, it means that they have this magic attached to them. I made up this word today, tuple callable. They are tuple callable. As in you can, if you have type A and type B that individually implement this onTimestamp set, you can also call onTimestamp set on a tuple of A and B. Like so, multiple items, or a tuple of 3 items, or 4, and usually you have to specify up to how many items. Okay, this is new, it's very valuable. It's a GIF, let's see how it works. It's a new way of producing content. One more time. The video starts here. All right, so what I'm trying to say is very often when you're dealing with macro-generated code, not just Frame, but Frame is one example, if you make some silly mistakes, especially syntactic errors, like in this case, what was I doing? There was a macro called callIndex, and I just added 2 X's to it. You are faced with this situation where you get like a gazillion lines of error, but except for the first error, all the rest is the artifact of the first one, something not working, and this just generates a lot of more errors. So it's a very useful tip to know that when you see these scary, oh my god, what have I done? Usually you scroll to the top, and that's your clue of solving the issue. It's funny, sometimes it's this is for a palette. I think for palettes we have improved them a lot, and the errors are reasonable. I think at the runtime level, we have some macros that are still a little bit more legacy and generate like really a lot of things. Sometimes your terminal history runs out. Like literally you have to what I do is like I run the command, I scroll up a little bit so it doesn't snap with it, and then I can debug it. But yeah, this will be, I think this is a feedback or a lesson that we learned from the previous rounds. It's the first time, it's a very good tip for you to have when you're debugging macros. And the last thing I want to cover, which goes back to the arithmetic,
Yeah, Mauricio, I just wanted to add one thing on that type of errors. Yeah, so for example, in the runtime aggregation, right, the construct macro, while you are implementing palettes, config threads to runtime, and you didn't include that palette in the construct runtime macro, you will get an error while implementing that config with runtime, which is kind of like crazy errors. But one thing is just you have to include that palette into construct macro. That's it. Solves everything.
So if it's one case where if I've heard correctly, you're saying this tip also doesn't apply, like as in it's just something you need to know by heart, please open an issue as in, hey, I'm a frame developer, construct runtime, this macro that you will learn about later this week, has this behavior where a very common error doesn't have a good error message, and we'll fix it, or we'll work on it.
Okay.
Yeah, please make an issue. I mean, this tip apply to most cases, but may not cover all. So, yeah.
So, Sukhmeet again, I wanted to ask this, that if do we mostly, when you are discussing about macros, is it declarative or not? Like compile time, like procedural macros, like which ones? Because
so they are both compile time, declarative and procedural, and at the moment, not almost all non-trivial macros of Frame are written using procedural macro syntax.
So they can,
that's mostly an improvement for us. I mean, here hypothetically we could have provided users with the same experience, and it would have been more pain for us to maintain this declarative macros, but yeah.
So the preference is primarily to use procedural in Substrate. Is that a fair statement or no?
Is that a what?
Is like that a fair statement? Is the preference of to use?
Yeah, but it's a preference for the maintainers. I want to emphasize it's not a preference. Like it doesn't affect you. As I said, we could have the same, almost the same. Okay, I mean, there's minor differences where it affects users as well, but yeah, it's a decision of the developers. At high level, I can say procedural macros are more powerful.
Yeah.
But there's some more boilerplate, so it's better to use them. Mostly, it's better to use them. But I want to emphasize there is also very easy macros that are much better written using declarative macros. So it's not a binary yes or no situation. Yes. All right, so and the last thing that I want to cover, I think it's the last one. Yeah, almost. Which goes back to some of the arithmetic and failures there, is this concept called defensive programming. I think this is also where we circle back and we revisit the same concept and wrap it up. Read this line first. It's a definition of what defensive programming is from Wikipedia. I put it here because the definition, coincidentally but rightfully, is actually very correct. The part that is bold, like it's useful in systems of high availability, safety, and security, which is literally what very accurately describing what blockchain systems are implementing usually. And what is it saying? It's saying that it's a mindset. Let's say that when you're writing some code, you should put all your you should write it with the anticipation that whatever you think won't go wrong might go wrong actually, for various reasons. And I had this like very silly example at the beginning that I'm kind of repeating here. Let's say there's some optional value, and you know it's some. I mean, for whatever reason you're defining as option and you're setting it so it's never going to be none. And what I coined this like aggressive program, like mindless programming would be that you just make that assumption that, I'm the developer, I'm the god of, I know what I'm doing, unwrap. Boom, like you're done with it. A little bit better, which is what we learned a couple of slides before, was that you do expect. So at least when your future self sees this, remembers why you decided to go for the aggressive behavior. Or a little bit better, and this is what we do in Frame as developers of Frame for our course. So this is the best practice that, let's say, professional Frame developers use, is actually like apply. I know this maybe value is never going to result in an error, but I still write my code as if it will. So I still do like okay or, and some error might happen. And usually you give that error some name that also says, this is a defensive error. Like I think it's really never going to happen, but it might. And I want to emphasize this first line of this example is like trivial and naive. Like most often it's not like that. Most often it is actually a little bit. We're all human. This is actually what I'm trying to say in the last one, right? Like I'm only human, I can fail, whatever. Like most often it's more complicated than this. Like you have nested functions that are calling one another and you kind of know that, in that 3 functions above me, I'm returning some, so it's some here, and you're making an assumption, but you might change the other one, forget to update it here. There could be legit reasons where you want to write your code in a defensive way. Or sometimes it's written on other components that you don't even know. You might be relying on an API that's saying, I don't return an error under these conditions, but there might be a bug in that other API that someone else is implementing, so on. Like there could be a lot of reasons where you want to write your code in a very defensive way. I don't know. Yeah. What am I saying? I know this will never happen, but I'm only an ape and can make mistakes. It's not. I'm just. I was trying to throw a joke there. I guess I don't know. Humor.
Excuse me.
Yes.
Is there a performance difference between unwrap and OKR, or it's the same under the hood?
So it's. Yes. It is like probably a few extra flops of CPU like operating, but it's probably worthwhile. Although I'm not sure. Maybe there is. No. There should be. Oh, right, yeah. I mean, panic is actually, yeah. So between unwrap and expect, there's might be some minuscule thing, but they're both panic. And actually, in terms of like, let's say, what will happen afterwards, panic happens to be extremely, like you just like unwind and very quickly your program terminates, but you're also in a state that you don't want to be. If you handle the error, it depends on your call site, right? Because when you do this question mark operation, you return
happy case scenario.
In the happy case.
Yeah, like unwrap works happy, so is it
it's
like better? I don't know.
It really depends on like the machine code that's generating. But my guess, and based on my previous minimal experience with assembly and such, I'm guessing it's more code. But the happy path shouldn't be much different because you're just sequentially. At most, it's like one extra jump or something. I'm guessing at the very low level. But it's code that's never executed. Defensive.
You're saying best is the approach that most of the professional developers take, right? Like professional Rust palette developers take.
Yeah. This is more of a frame thing than a
recommended.
The whole point of Rust is that you have explicit error handling. So any professional code base should not have unwrap wrapping around. You can just do it better, right? So it's unwrap is a tool that exists for the purpose that I don't know how to say it.
just to clarify, the part that I said is more of a frame thing than a Rust thing.
That's why I asked, because I wanted to know what you guys have the opinion, and we follow that same thing. Okay, glad I asked that.
Unwrap or is not.
I will read your code. I will be able to process in my head what is going on. You panic.
You have.
Yeah, I got. What? No, it's my turn. What about when you have a match statement and you have a wildcard arm and you just wrap it to unreachable? Is that okay?
I think it's a very similar situation. If you want to be non-defensive, yes, but that would also be something that is like a violation, let's say, of the defensive programming paradigm. It's unreachable, but you probably want to put some code there that handles it. The wildest case is like this story of have you heard of this election in Belgium that there was discrepancy and they eventually tied it back to some cosmic ray caused a bit flip on a computer? It's very, very famous story. You should check it out. Worst case, there could be a bit flip, random bit flip on your computer, and that unreachable might be case. Do you prefer panicking or writing a few lines of defensive error handling? Right?
Yes. Okay.
Yeah. But unreachable is very similar in my way of thinking to expect. You're expressively saying this line of code is unreachable, and you can give it some string as well that describes why this line of code is unreachable. But again, you want to be on the lower end of these examples.
So how about unwrap or default?
That's not a panic.
Huh?
That's not a. So it's a good. That doesn't panic in any case.
Okay.
It's a handled actually. It's a case where you're saying if it's none or error, use default.
Okay.
Yeah.
Cool.
Right, so, but maybe again, like unwrap with a parentheses is what he was referring to, not unwrap or. Yeah. Yeah.
Not just, I'm looking, unwrap and inspect are two ways you can panic, but I'm looking for panics, and you're not allowed to panic at runtime.
Gotcha. Thank you.
I actually use this as a segue and jump into like the few slides ahead of myself where I actually talk about this. So there could be panics other than cases than none or error dot unwrap or whatever. And where do I have the examples? Oh yeah, let's talk about some examples. So what else other than what Sean said that anyone knows about? At least in the standard library. I think there's one example that I really want to emphasize, or some. Right, yeah, the vector stuff. I think there's some good panics to know about in vectors, for example, popping an empty vector, inserting with an explicit index that doesn't exist, or using the index operator at an index. These all panics. Which takes us to the question of how should we know about them? You should read the documentation of that type, which brings me to my next point, which is especially when you're writing APIs that you expect others to use, or you are using some kind of API, it's a very nice thing to do to read other people's docs and write docs such that others can easily know if this function or API that you're writing will panic or not. I tried to set good examples. We tried to set good examples of this in all the material that you've seen so far, like the exam, all the assignments so far, like the templates and so on. We're intentionally trying to set up this framework in your head. You have function, describes what it is, maybe an example, and then a list of, in your assignment you had errors, but very often in the Rust standard library you see a section at the bottom of any type or any functions documentation that explicitly says if this function panics under certain conditions. All right, let me go back to this final slides that I have. So one last introduction. So these last two variants, which are our preferred way of handling these defensive scenarios. So this is probably not going to happen, but unless if you made a mistake elsewhere, you still want to handle the error. We can agree that if this error happens, so for example, the error called defensive error, if it happens, there must be a bug somewhere in your code, or you have made a mistake, or a, cosmic ray has caused a bit flip. It's a scenario that you definitely want to be aware of. So the code that ideally you want to write is something along the lines of this, the same option, okay, or, the line is long, you can't see the end, but it doesn't matter. Map error, so in case this thing was an error, so in case this impossible condition happens, my preference is to say, okay, if I'm in a test context, panic, because I'm in test, right? That's fine, I want my test to stop. If I'm in my non-test or a production environment, log a very scary error message that says, hey, that impossible condition that you thought never happened is going to happen, actually happened. And it's not nice to need to write this every time, and Frame comes with a set of traits that operate on options and result, and they're called defensive traits. And the syntax is hopefully intuitive. They're called defensive, whatever else you want to do. And under the hood, they exactly do what I just described. So especially in your, it's in your assignments also nice, but actually in your assignments also really helps you, because you can then, in your tests, when you write tests and you have this unreachable codes, it actually helps give you coverage that in none of your tests that unreachable code is used. But extremely useful for more production environments as well. It does this process that I described under the hood.
Excuse me?
Yeah.
Yeah. In the previous example, if the left-hand side of the bit... No, one forward, please. Yeah.
This one.
Previous one. One slide back. Thank you.
This one?
Yes.
Okay.
So if the bit that changes to cosmic error is the value, then it's pretty much there, right? You know what I'm saying, right?
That's a different scenario. So I'm talking about the scenario where this
equal to right-hand side. If that changes, then we can trap it with
That's
this.
a different scenario and not going to be caught by the things I talked about. But if that impossible bit flip will cause this maybe value to become from sum of something to none, then it will help us.
Yeah.
But yeah, if it turns from sum of 1 to sum of 2, that's someone else's problem or not. Yes. All right, so I think that's actually it.